All right, welcome back. So we'll be working on these exercises, and we'll be looking at how we can make use of FDs and SCs to control this particular process. So this is for training purpose. This is for training purpose. All right. So let's just give an address. Can you help me write out the address we used yesterday so we can assign addresses for each of these? All right, thank you. We have the addresses now. Where's the start? All right. So let me just explain how this process actually work. Okay. For this process, you have pump one and pump two. So for this process, first of all, once you click your start initiate the system. On pressing start, pump two comes on, okay, and pumps till tank one gets filled up. This is tank one. This one. Can you see? Yeah, this is tank one. So once this pump is on, after like 5 seconds, when pressure is built up, this valve one comes on. I think I have the process analogy somewhere, but I don't know where I dropped it. Let me see. Maybe I will look for it. I have how it's supposed to work out. I will display that later. But let me just explain using this diagram. Pump 2 comes on, then after 5 seconds, the valve comes on. And when the valve is on, it pumps till it gets to LX2. Okay, it gets to level switch 2. All level switches are normally open. So let's not mix it up. All the level switches are normally open. Then once it gets filled up, once it gets filled up to LS2, it stops the valve it stops the pump first, then the valve. Yes, it takes it 2 seconds. Okay, it takes after 2 seconds, it stops the valve. So after it stop pumping, pump one comes on. As long as there's a pressure at PS1, PS2, and PS3. So it's a three pressure. So as long as there's pressure there, it pumps into the second tank, and valve 2 comes on, then fill up valve 3. So as tank 1 is going low, pump 2 will come back on and continue filling. Okay, once it gets to LS4, it keeps pumping then till it gets to I think I updated this because I drew this in SCADA. I updated this program later after the training, but I think I don't have it here. There's another level sensor here. I added another level sensor here halfway. So once the tank is halfway filled, this pump stops. Is it halfway filled? Yes, this pump one stops. We'll take it gradually so you get to understand. I have the philosophy of how it works. So once it gets halfway to this tank, then when it gets halfway, it have to start repumping in while this one is still working. This pump will only stop when it gets to LS1. Maybe there's an issue, there's no flow or there's no water from the reservoir. That is only when it's going to stop, and this will keep on flowing till it flows out. So that is the job. So, but what makes this program different is we are going to be making use of F-beats. Okay, what we'll be doing is we'll be having pump control block, and valve control block. Pump control block, valve control block. Yes. For the pump control block, we are going to be imputing what we call a dry run sensor. I think I don't have it here, so I think I added it to the next program. I will look for the program. If I didn't take a screenshot, of it. A dry run sensor, what does that mean? There's a small sensor before the pump that actually detects that there is fluid to actually protect this pump. Okay, to protect the pump. So yes, you might click on start, and if there's no liquid before here, and you are running that pump on dry, you can actually spoil that pump. So that's why you need a dry run. We call it dry run sensor. It's just a flow switch too. So the dry run sensor can actually detect first that there is flow. So if you press start and there's no flow, to give you an alarm when you see that dry run fault, then stop the system. Then you have to reset and restart the system. I would have to look for the full program that I look on this. Okay, so before the valve comes on. Okay, so I'm going to be designing a block, like I said, a pump control block. So these are going to be the input of the block. We're going to have the start. We have the stop. We have start, stop. We have dry run. We have status. We have auto mode. We would have run signal. This is the output run. Most times, then you put it out. Output. Okay, output one. We have the status. So start, stop, dry run, auto, output, and status of the pump. The status of the pump has five colors. Okay, 5 colors. If you are running on manual, as you can see here, if you are running on manual, this green, that rectangle inside that box will be black. They are running it on manual, not auto mode. No, auto mode you have to use that start and stop. But on manual mode, Once you click that pump, to bring out the faceplate where you can put it on auto mode or you can press start and stop. On the HMI. On the HMI, yes. So you use memory bit for that first. And when we get the HMI, we now start using our bits and all. So we have a lot of things to cover. So for the pump, we're going to do manual mode. Manual mode for the pump, everywhere will be green, here will be green, and here will be black. And when it's stop on manual mode, here will be black, here will be blue. That is for manual mode. If it's on blue, you know you're on manual mode. If you're on auto mode, everything will be green. Both this is green, the box inside is green, and if it's on stop, everything is blue. You can see it here. So when I took the screenshot, this pump one was blue. It's on manual mode. So you have blue, blue. This one is black. This one is black. Okay? Blue. So these are the four states. And if there is any error, maybe dry run error or whatsoever, everything is going to be red, red. Okay, let me display how it will look like for us. Okay, just to give us an idea, so it's a lot of jamboree, but it's very, very, very needed out. Let me display it now. Okay, just some minutes. Okay, so this system. Just a minute, please. I don't know where I kept those down. And I saw it today. Tag data. I called it resources. Uh, let me open it from our project. So while we are waiting for that, but what we get the logic of what we are waiting. So this is going to be making it of some move instructions and the like. Okay, for it. So but first of all, we'll be writing this using an FC in search works. So we'll use FP to write. Hope we get the logic. Let me explain again. We are starting manual start and stop. Okay? Start on manual, stop on manual. So we have dry run, that is the sensor, and we have auto mode. It's on auto mode. waiting for the auto command. The manual mode is waiting for the manual command. And there are different states. They are running on manual, how it will respond on HMI is different from when they are running on auto mode. What does that mean? Command the auto command. The auto command is going to be given by um, the auto command is going to be given by the PLC. The auto command is given by, what is this diagram I want to open? Sorry. This, yes, it's going to be coming starting from here, from the HMI. Start process, stop process. So everything is going to be coming from here. Okay, so now let's start the program. Okay, I think we have done our hardware configuration. Then I'll just go to my main block. Engineer Maio. All right, so let's add a new block. Are we together? Yeah. So double click, add a new block. I'll write this one for us. We're going to replicate the same thing for valve. Okay, so I'm going to create a function called FC. Okay, I'll call this pump control. Okay, and I click on OK. I'm writing in ladder, so leave it in ladder and click on OK. All right. So we said we are starting on manual. Are we together? Okay. So we're going to do auto or manual mode. Okay. Let's start by doing the manual mode first. So I add the contact here. Okay. Add the contact here, and just to show us how FC work, we'll just do a quick manual start and stop. Just to show you how FC work before we do that. So give me an address of a green push button. Okay. I0.5. Then I can rename this tag by right clicking rename tag. I call it start push button. Okay. Then I give it an output. Let's see. Output is Q0.0. Let's see. Is ID 0 for the output system. So I rename this. I call this output. Call this pump. Okay. Okay. For my stop, yes, red push button I2.1. Rename this as stop push button. Okay, and I'm going to latch this with pump. Okay, I latch this with pump. Alright. I also want to put a command to be able to select between manual and auto mode. I'll just use a switch for that. This is just a simple program. Let's use I3.6. Since we have manual and auto mode, we must be able to select if we want to do manual and auto mode. Okay, so I rename this as selector the manual / underscore auto. Manual. No, manual is it works both manual and auto. It's off is on is on is off is on auto. If it's on is on manual. So that's why I'm doing it this way. Um this guy is not supposed to be here. Supposed to just be here. This is manual mode. Okay. Then I repeat this same thing. This for manual mode. I can do something like this for auto mode. I have this same contact. This when it's on manual mode, I would need a condition to actually start it. Hope you get this manual mode, this auto mode. Okay, I'm just trying to just do a simple program. I just want to show you how the FC works. Okay, so and I just call this a memory bit M4.0. Let me call this, rename this and call this command. We just call that command so that once we are on manual mode, we wait for this command to actually run it on manual. And as long as the command is there, it will remain on manual mode. So can you try this out? You're going to do the same thing. Then how do you call it into your OB1? Okay, you just drag and drop. It has called it now. So anytime a PLC is scanning your OB1, you said this is a what unconditional call. Conditional call, I may put a bit in front, right? Put a bit in front, a condition before it runs the program. But now I'm calling it unconditionally. Let's see how this works. So I'm going to give you some time to replicate this. All right. So go ahead. Should I test it? Can I get the MPI cable? I can also test this. Alright, so we're going to test this program now. I'm just going to click this and download. I'm using MPI, so I would have to set my PLC interface. Alright, I'm using MPI. So I can use automatic detection protocol. Okay, and I click on start. So the CPU is Ethernet compatible, but let's just use Ethernet. And I click on load. So I'll allow you to test this once I'm testing. Alright, start module. Alright, so I'm going to monitor this. Let's see what we have done. I'll monitor this. Let's see. Okay, so currently the switch is turned off. That means it's on auto mode. So it's waiting for this command, which is supposed to come from that our HMI starter stuff. So I'll just trigger this. Control Shift F3. I just right click and modify to 1. Okay, so the output is on, but it looks like you made a mistake in the wire, and the output came on and it's just blinking. It's just blinking. Then I can turn it off by pressing Control F2, 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 on, off, on. You notice it's blinking. You can see that red is blinking. It's coming up on the mode quite alright. I mean, the actual output is not well. This is in auto mode, and for
because okay, this is normal.
yes, help me toggle the switch. That is the manual auto switch. That will be the first one. The up one, yes. No, it's the other one. Sorry, the one down.
This other one.
No, the first one. No, as I told you, that's why this was an assignment yesterday. I can't see I 6.3.
3.6.
Press start. Start is getting here, but that I 3.6 was not properly wired.
Let me
That is 7. That is 6. It's on now. Now press start. Yes, it came on. It came on. It's on. It's on.
I still made mistake.
So which of the switch works?
It's still the same the first one.
But it's the other way.
Yes.
Okay, alright, that's fine.
I need to correct.
No, you can leave it like that. You can leave it. As long as you take it off.
Yeah.
No. Yes, now then I toggle it from here.
Then second one. Other way than the second one.
Okay.
Selector switch.
So it's on. So the both are working. So let me show you the main thing I wanted to show us here. Is from your main program, you can see you call the block
Pump control.
pump control here, yes. So as long as you have called this block inside the OB1, you can monitor whatever is going in here. If I make this a conditional call, let's say I call this M4.1. I make this M4.1 and download this to the PLC.
Sorry, you have to pass.
Oh, sorry. It's just a simple line. Sorry. Alright. So I've toggled this on. As you can see, I've made this a conditional call. Let me split this screen into two. So you can see the both sides. I won't be able to actually go online to monitor this guy. Okay, I should, but in the last state, you can see it's not running. Can you see what I'm saying? Showing you rather. You can see it's not running, nothing is running here. Okay? Because the condition is not met. If I toggle this on now, you can now see that the condition is true and thereby this comes on. If I toggle this off, okay, the condition remains at that state and the output will always be on. If you go to PLC tags and try to check all addresses, show all addresses and monitor, it remembers the last state of the output. You can see the pump is still on. Let me adjust it. You can see the pump is still on even after this condition is not true. So that's what I meant by, as long as you have a conditional call, the PLC does not enter into that block to scan it. It remains, every other details remain as it is. Okay, so even the command is there, the command is not there, it's not going to have effect because the open entering into is not entering into the pump control block to monitor what is going on. So it's just monitoring it to this point. And if you monitor the scan time, I don't know if this shows scan time here. Okay, this is not showing yet. Okay, it's supposed to. I can see that from online and diagnosis. I will surely give you the cable. You can actually do your test. Okay, so like let me run past shadow. You get what you are doing. So we come to memory. Is it memory or cycle time? Yes. You can see the cycle time is 0. It's not doing any work. Are you trying to get what I'm trying to say? It's not doing any work because you have called that block into an FC and it's just scanning. There's nothing for you to scan. There's no work to be done. But once I toggle this back on, you see it's still showing 0 because the time is taken to scan it is very small. The program is like chicken change for it. It's too small, yeah. So it's quite very fast. It's very fast. Yeah, you need every program on it. Put an every program now, you can be seeing 70 milliseconds, 20 milliseconds, and the likes. All right, are we together?
Yeah.
So I'll allow you to do this test now. I'll pause the video or mute the video a bit so that you can carry out your tasks. Let him test. So once it's done, we're now going to carry out this function block. We'll see how function block would work with a DB before we now move fully into writing the